Welcome to day 0 of chapter 5. This video is a review of factoring. So this is stuff that we covered in Algebra 1 and then you probably covered in geometry, and so now we're doing factoring again for a third time. We're going to have 3 different types of factoring. First one is we're going to use GCF, greatest common factor. We're also going to use product of sums and then difference of squares. And then we have examples of all 3 types. So the most basic type of factoring is greatest common factor, GCF. So what you do is you look at the 2 factors and you find what they have in common. So I have a 16 and I have a 4. Largest number that divides evenly into both is a 4, so I'm going to factor out a 4. My first term has an x, my second term has an x, so I'm going to factor out an x. And then I have y squared and y. I have to take the lowest power. Y is lower, so I'm going to factor out a y. Okay, I'm going to erase that now. Okay, then in parentheses is what's left. 16 divided by this 4 gives me a 4. I had an x, I took out an x, there's no more x's. And then I had a y squared, I took out one y, so there's one y left. Okay, 4xy, well I factored out a 4xy, so that leaves a 1. That's the one that students forget about most. And that 1 is just a placeholder. Now to check my answer, I just need to multiply out again. 4 multiplied by 4 gives me, gives me 16. 16, so I get 16xy squared minus 4xy, which is what I had originally. So this is my answer. Let's do one more together just to make sure. So looking at the next one, I have 32, 8, and 16. Largest number that divides evenly into all 3 is 8. And then I have x to the 4th, x to the 3rd, and no x's. So I can't factor out an x. Then I have y to the 6th, y, and y. The lowest power is y, so that's what I'm going to factor out. Now 32 divided by 8 gives me 4. I didn't factor out any x's, so I'm left with x to the 4th. I had y to the 6th. I took out a y, so that leaves me with y to the 5th. 8, I took out an 8, so just a 1 stays. X to the 3rd, and then I already took the y out. And then 16 divided by 8 is 2, and I already took the y out. So this is my final answer. And then if we were to distribute the 8y, we would end up back with the polynomial that we had to begin with. Right now, pause the video and try this third example on your own, please. Okay, you should have factored out 8xm. You're left with 5x squared n plus m squared. Hopefully that one went well for you. If not, go back and see if you can find your mistake. Okay, moving on. Now we have difference of squares. So difference of squares, difference means we're subtracting, and then squares are perfect squares. So in the first example, we see we have 9, which is 3 times 3. We have x squared, which is x times x, and 25, which is 5 times 5. So these are all perfect squares. And I have a difference. I'm subtracting. So this factors into 2 sets of parentheses. Now I need to take the square root of 9x squared. I get 3x and 3x. 3x multiplied by 3x is 9x squared. So that should make sense. From the 25, I have a 5 and a 5. And then I get 1 addition and 1 subtraction. And that's the final answer. If I were to multiply that out, I would get 9x squared subtract 25. Okay, let's look at the next one. I need to think what multiplied by itself gives me 25. Well, that's 5 times 5. What multiplied by itself gives me x squared. So that would be x and x. So I get 5x and 5x. And then the square root of 64y squared is going to be 8y and 8y. And then I get 1 addition, 1 subtraction. You can flip the order of those. That's fine, doesn't matter. But you do need 1 positive and 1 negative. And again, this only works for the difference of squares. So instead, if it had been 25x squared add 64y squared, this would be prime, which just means that it's not factorable. There may be a GCF, but that's it. Okay, pause the video right now and try the third example on your own, please. Okay, so we should have gotten 4x squared and 4x squared. That gives me 16x to the fourth, and then I get positive 1 and I get negative 1. So hopefully we got that far. Now this one's a little trickier because we notice we have another difference of squares. 2 times 2 is 4, 1 times 1 is 1, so this factors again. This is going to factor to be 2x and 2x, which gives me 4x squared. And then I get plus 1 and minus 1. And then this one out in front, this 4x squared add 1, that does not factor because that's an addition of squares. So it's a sum of squares, so that's prime. So this is the final answer. That one was tricky, so if you didn't get that one, that's okay. I would have expected you to be able to get this first step though, even if you didn't get the second one. Okay, last type of factoring is product sum. So we have 3 different examples here. Remember that product means multiply and sum means add. So I call this the product sum because you're looking for the 2 numbers whose product is this last number and whose sum is the middle. So this is like having a 1 in front. So I need 2 numbers that multiply to negative 72 but add to be positive 1. Well, 72 is 2 and 36, which obviously can't add to be 1. And remember, one of those has to be negative. It's 1 and 72. If you make either one of those negative, they're still not going to add to be 1. 3 and 24, if I make one of them negative, still doesn't add to be negative 1. 4 and 18, I make one of them negative, still doesn't make a difference. 5 doesn't go in, so you got to keep doing this. Eventually you're going to get to 9 and 8. Well, if I make it positive 9 and negative 8, those are going to add to be 1 and multiply to negative 72. So now, this factors to be x add 9 and x subtract 8. And that's it. Okay, so the next one, I'm looking for the 2 numbers whose product is negative 18. They multiply to negative 18, and whose sum is negative 17. I'm going to have an x and an x. Okay, so 18, that's 1 and 18. 2 and 9, 6 and 3. If I make one of them negative, so like a negative 18 and a positive 1, that's going to add to be negative 17. So I'm going to have x subtract 18 and x add 1. And that's the final answer. So last one, pause the video right now and do the third example on your own, please. Okay, so you should have looked for 2 numbers that multiply to be 6 but add to be 5. So you should have had x add 2 and x add 3. If these were in the reverse order, that's fine. So you could have written x add 3 and x add 2. The only options, though, were positive 2 and positive 3. So hopefully you got that one right. If you have any questions from the video, please bring them to class tomorrow. We're going to be doing some more factoring review. And then we're going to be doing factoring later in the chapter also, so this is going to keep coming up. When you come to class tomorrow, we're going to do some examples. Thank you, and see you tomorrow.